is to develop new services on top of the architecture, on top of the digitalized data, on top of the interfaces that have been defined. And if you open up that for universities or startups or community development, I think there's an innovation force in this that is really to look for and to try to get to. Yeah, you had a question, or you wanted to?
Yes, I find this ladder extremely interesting, and I think it's highly relevant for Nairobi and Kenya. The way mobile phones usage is booming in Kenya with Safaricom, with M-Pesa. Now, is this ladder and this approach, is this what they're taking in Singapore for the Smart Nation concept, or in Abu Dhabi? Is it something like this, or how could this be implemented? What are the steps to follow this ladder and achieve this?
Yeah, I'll come a little bit to it in a second,
yeah.
Because I think I'll give you a few examples on cases that we have done, and just to give away a little bit, the prime insight is really to identify the service that from your perspective gives best impact or benefit to either the society or the individuals or the business. And if you have identified that service, you take that through this whole ladder. And in our belief of establishing the solution around that single services, you will find a lot of multi-service enabling from that infrastructure and from those layers. So if that service is in energy provisioning, or in water management, or in transport, traffic management, it is for you to judge, of course. But once you have identified the service, it's much easier to deploy this ladder.
So it's really service by service one should think about this.
Yeah, in my mind, or in our mind, it is at least the way you should start with it. With a little comment on it, because the key starting point, if you have done the architecture, and this is not building or digging things or pulling cables, defining the architecture is like the drawing of the common building blocks, so that you do not start to deploy projects individually like stovepipes, and then when you have 3 of those implemented, you find out that, hey, why didn't we think about that this one should talk to this one? A nice example that we see in the combination of the energy and transport sector is the electrical vehicles, and where we as a total globe, we cannot afford to have the classical gas-driven car system. So electrification of vehicles, of public transport, buses, and of trucks is one example where the energy sector and the transport sector needs to have a solution that works. So and that is what I mean, that the architecture would be possible to identify.
Do we have questions on this so far, or thoughts? Should we talk examples? Okay.
So this was just to illustrate the digital representation. I mean, that basically everything that you have as resources or assets in society can be represented digitally as a basis, as a foundation to actually use that in the information and communication systems. Connected mobility. I think that mobile management or mobility management in urban areas is one of the biggest challenges that we have as a global community. The urbanization trend, you know better than most, what challenges that gives. The trick here, we believe, is that you will, over time, expand the number of capacities or resources used in the transport system. It can be everything from private cars to taxis to bikes, public transport, of course. But also, if you look upon the urban commuting of workers, what sort of distributed office environments can be done. And that could be enabled also with the information and communication technology. In order to make individual choices, how should I go travel? I need a lot of information from these resources. What is the availability? When is it leaving? What is the price? Can I book a seat? And if I'm environmental conscious, what is the emission of the choice that I actually take? And once I've done that, I want to plan my travel. So I want to set my preferences, I want to make a booking, and I want to be secure to make a payment. And of course, if you are a transport authority or a rail operator or a train operator or a traffic management center, you would like to have some management capabilities to influence this. Either influence it by regulation or influence it by by, for instance, dynamic pricing, like congestion charging or varying fees for the public transport. So what we believe, in order to facilitate all this, again, 2 simple steps. Secure that you understand all the assets, have those assets digitized, and secure a solution how to connect it. It doesn't have to be through the mobile network, all of this. I'm not trying to push radio base stations down your throat. I'm just saying that the access to the data that gives the information to the services on top, and these services can be travel planning, it can be, again, ticketing, the services can be traffic management or route management of different kinds, and it can be also commercial offers, of course. We are looking into doing trials now to attract people to go certain routes due to the situation in the traffic network. Are people interested to actually, if they have a choice of A or B, going to C, if we have a commercial offer saying that, you know, if this is a morning commute, you will get a breakfast package or an extra coffee if you pass by this station and these coffee houses, compared to if you take the other. Might not be applicable in Kenya, but it's been a discussion we had in London with Transport for London, for instance, and also in other countries. So again, secure the knowledge about the assets important for the whole transport system. Secure that you have those digitalized as good as it can. Have them connected, and define again which is the most important service that has to be driven on top. And then with this in the transport system, we have a lot of discussions now about autonomous driving. The whole car industry is moving from personally driven cars into autonomous driving cars. I don't think you should make the translation of today's car owning model into tomorrow's autonomous driving. It might be a perfect resource and a fleet management solution for the capillary network of the public transport. But it's again, it's an evolution step, so it's good to make philosophies and have, say, examples or visions in what will this mean. But again, it starts with connecting it, and it starts to defining services that actually makes the collaboration in the transport system, so that it's not seen as individual building stones, but rather a complete system of infrastructure, vehicles, goods, travelers. We have a simple 5 steps areas that we believe is important for this architecture. And it's a little bit, again, depending on where you are. It should start with what's on the top. What is the primary service of choice? Again, is it a transport related, a commuting related, an energy distribution, a water management service, or healthcare or education service? What is the need that you would like to address? And then think simply in all those 4 areas. What is the infrastructure that we need now to connect the devices that is required, being the train or the signal system or the station or the cars or the travelers as such? What is then the way to manage this connectivity? You have a national responsibility or a city responsibility for the infrastructure for many different purposes. The 3 operators that we saw and that we are all doing business with may have good or complementary services for your needs, but it might be so that you need to think about the connectivity from the service and not from whatever that single operator were ready to deploy. And here is where we step in now, having supplied all the technology and running those networks for the operators in the world, to actually help you to say, well, if you have this type of devices for this type of services, what is the way of connecting those, and how should you be able to perhaps use a combination of the 3 operators rather than one or the other, in order to find an optimal solution for defined services. And also a level of managing the asset. If the asset is again the pump, or if the asset is the train, or if the asset is the crossing or the station or the information signs, those also require certain attention. And here you choose, of course, what is, so to say, required. And when I said before that you start, at least what we believe, with one single service and then make the solution, and then find that once we now have done the infrastructure for the connected rail or the connected train, for instance, for the rail management or the train remote diagnostics. You may use that infrastructure for the signaling system, or you might use the infrastructure for providing infotainment services to travelers, so that you can actually have internet services on board of the trains. With, of course, no conflict, should be no conflict in the radio or in the communication between the mission critical signaling system and whatever internet coverage that you have on board of the trains. So this is just I think I have to hurry up a bit, but this is a easy way to identify, based on what I said before, how to start to build the architecture, what services do we want to deploy, and what are the primary users who are on top. It's also measuring the city experience of that service. Is there a good enough coverage to use a travel planner based on a mobile phone in the city of Nairobi? Or does it need to be network tweaking and quality of service improvements of the network? Is there a possibility to have the mobile phone and your existing mobile money system for public transport ticketing and payment of an A to B trip, where you might have a combination of going by train, going by taxi, going by a rental car is perhaps not a good example, but a mixing, a multimodality of a trip from A to B might require a payment solution that can be very, very nicely tied to the system you have around the mobile phone. So, having said that about implementing the service, it's a daily operation required as well. As I said initially, we are today managing mobile networks with 1 billion subscribers in totally globally. So we feel pretty confident in running this sort of operational centers, securing that the network is functioning, securing that there are no big surprises, securing that it's a data security environment, that user data integrity can be protected. And this we are now applying also in the public safety domain on emergency network operation centers. So emergency response centers like 112 or 911 to actually get information about accidents or incidents and dispatch blue light resources. And we are also doing that in the traffic management environment. So the one of the examples that we talk about in many cases is a city in Brazil, São José dos Campos, where we have integrated the whole emergency management system with the traffic management. Just one very simple example how you can organize a green wave in the traffic light system for emergency vehicles when you have an ambulance or a fire or police rescue team that has to come through. And what we also see that in many modern cities now trying to see the benefit of actually integrating this, not to have operational centers discipline by discipline, but really see the benefits of having it all, managing all fleets in the city, having a joint reporting of all incidents that might not have to do with all the disciplines from the beginning, but it might be good if the public transport operator knows that there is a fire in a factory at some place, or that you have a planned incident in the electricity network somewhere else. So bringing operation centers together in urban areas is something that we see, and we definitely are ready and available to support. This is not about technology only. This is even more about changing behavior and changing processes. So we have what we call a transformation framework to go through different phases of assessing the situation, planning for the change, realizing it, and then optimize it as we walk by. And this not only for what I talked a lot about, the network and the information and communication technology, but also for the operational processes. And of course for the business as such, if this is for a private operator or a transport operator or something else. So this is not easy things to do. These are challenging stuff to do, and technology is an enabler, but just adding technology does not make it function and successful by automatic. Is basically my message here.
Before you get into the cases, do you want to check for the questions?
Any comments or questions on what we said so far?
Would you just go through the emergency?
Sorry, go through
the emergency. emergency, this climate emergency, and how it works. That one,
You mean this one?
yes. And especially where you
We
are
have
dealing with natural disasters.
Yeah, we have two parts in this. One is what we call a critical infrastructure protection. So that is basically a generic solution where you have a lot of sensors that gives information about special events, or if you have flooding, or if you have an earthquake, or if you have a storm or something, different type of sensors. That can also be applied on specific areas, like a border. So sensors for people walking, or sensors that actually sense movements, or you have image recognition. A lot of sources that event is happening. That's being transferred into an operation centers where you have people surveying and looking at screens, or having autonomous incident alarms. And once there's an incident that you should act on, how to dispatch a mobile workforce, how to send a rescue team, or how to send a border guard team, or how to send another type of mobile team to actually act on that incident. So it's a combination of sensors, communication of sensor data, intelligence to dispatch whatever that data says, and the tools and communication to actually have the mobile workforce act as efficiently as possible.
I actually brought it up because in Nairobi recently been having floods,
Mm.
and we find that people are not able to move for hours. And sometimes something hits my mind that should there be an emergency in Nairobi, which are the escape routes? And we didn't know what's happening in one corner of Nairobi when you're on the other. And I was thinking that if you're looking at having a railway network or system in the city, the design should have that in mind. In the sense that if you're going to have that, should there be a situation where you really need to evacuate a whole section or part of the city, there should be a way of detecting, communicating, and implementing the evacuation.
Yeah. And that is good that you mentioned it, because communicating or broadcasting messages to the public is one thing that becomes critical in this. And again, there where we believe that the capability of the mobile network is at hand, that you either broadcast a big amount of SMSs, or you have other different broadcasting technologies in the mobile network. But in order to send an emergency message or a guidance that due to this thing you have to evacuate in this area, or you have to go here and here, or here are links to other for more information. So that could be one interesting area. Thank you for the question.
There's another question here.
Two, actually. Can you do all these things without 5G? First question. The second question, when will you be able to roll out 5G in Kenya?
First question was easy, because yes, you can do a lot without 5G. I mean, this is a matter of finding, as I said on the slide before, I mean, how do you have, whatever type of communication you can have, you get some data. You may not get it as quick as you want to, or you may not be able to get as much data as you want to, but every communication gives opportunities. And for a long time, this whole telematic scenario was built on 2G. Now with 3G and 4G, we have capability of having much wider data, and also much more time-sensitive data. So to give you one example on what actually 3G and 4G could do in the traffic safety environment, is that we did in Germany with the German automotive industry, try to include a sensor equipment in the car that felt the pressure of braking. And if you brake hard enough, it's an indication that here's a very sudden stop on a very busy road. And if you don't brake quickly enough behind, you have a pile-up or a big collision. So here we showed how the mobile network could pick up the sensor and broadcast that to all the cars on the same way, in the same direction, within 350 milliseconds. So all of a sudden the mobile network is a tool to actually give traffic warnings and road warnings of different kinds. Now this was a research, it's not really ready for full deployment, but when the network is there, and it's a quite easy thing to add sensor capability to vehicles. And just one example, but with 2G it is definitely still possible, but with limitations. Question of 5G when in Kenya, I think you should ask the three mobile operators, because we do not implement and operate a network. I mean, those are our customers, and so that wouldn't be handled. I hope it will come as soon as possible. I guess it's a matter of what is the pressure that the mobile operator feels from society. And the use cases, this, you can keep me talking for some while, stop when we have enough. But if you think of it, the existing mobile network is driven by consumer needs. It's driven by our needs to say hi to each other, or to send an SMS to each other, or to go in and surf on a smartphone. Very consumer-driven business model. Now, and that is what has made the mobile operators successful, and what's the commercial core of their commercial model. The things we talk about here now are not primarily for consumers. That's for you running a railway network, or for you operating a city. It's new needs that the operators have to feel the pressure. So if you don't tell them that you see that this is applicability and these are use cases that can be actually supported by them, they will not. They will stay with the successful consumer model. So I think it's a matter of business development and market development here as well, where new stakeholders step into the market and formulate requirements that the consumer will never do. Also, any other question? Then before my time is up, I just want to give you a few examples on what we have done. I talked already about the Integrated Emergency Center and Traffic Management Center in Sausalito campus. Very clearly effect on the crime rate in the city, giving much more accurate information to the blue light services, and also be able to have a more efficient management of the incidents and the traffic as such. In the sustainability or energy side, in Stockholm we have been involved in a trial project in one of the new urban areas called Stockholm Royal Seaport. This is a totally new apartment building area. I'm not sure if you were visiting this or if you have talked about it.
We talked about it. We visited Hammarby Sjöstad, and there we talked about the next step being the seaport.
Yeah. So this is almost what you've seen, but 10 times, or they aim to make it 10 times more interesting and more efficient and more environmental friendly and so forth. So here we have been involved and see how can communication support the electricity provisioning and the so-called smart grid and the microgrid that can be established. On the energy side, we are not only busy on city level. I mean, energy networks are normally national. So, and the smart metering of including communication capability in the electricity meter at home or where the electricity is consumed is the main challenge for all the national energy provisioning companies around the world. And this is one example how we have helped one country to build a complete national smart grid network and deployed a smart metering solution for them. And when it comes to the connected cars, together with Volvo Car, we have deployed a solution that makes it possible for them to present and handle new services in the vehicle, and also to collect the data as innovation platform for totally new services as such. So this is for us stepping into the whole next generation of connected vehicle and what it can make for road safety, for traffic efficiency, for energy efficiency as well. We've done this, as I said, with electrical vehicles as well, with an electricity company, but also for infotainment, to get music and media and so forth into the car. In the transport domain, we have also done, in the logistics side, a project with Maersk. Maersk is the biggest shipping operator in the world, and they have some 440 container ships, where each ship carries some 18,000 to 20,000 containers. Pretty challenging radio environment when it comes to the steel environment to actually have radio communication on. But here we built a mobile infrastructure on each of those ships. So we put the 2G base station on the vessel that communicates with the 2G module in the climate control containers, so that the goods in that container could be maintained even during the shipment over the Atlantic or over the ocean. So for us, this was a close to Stone Age idea of thinking of communication, but applying an existing technology that we had in our portfolio in a way that became very innovative for Maersk. So now we are operating this on behalf of them, 440 ships going global, and with the satellite backhaul as well. And this is to me a good example of what I said before about the multi-service capability. This started only with perhaps 10% of the containers being remote controlled or climate controlled, the reefers. And for that we find the end-to-end solution. Once this solution was implemented with the satellite backhaul, Maersk found out that, hey, now we have actually paid for this satellite link that was so expensive before, and we have a business case for it, and now we can give that as internet browsing for our crew. And getting competent crew is a competitiveness for them. So now they can be a more attractive employer because the crew can stay in contact with the families and with the life back home. They also found that, you know what, now this satellite link for navigation, previously we used that only close to shore because that's where we needed the satellite navigation. Now we have the satellite connection all the time, so now we get a much more accurate position to the traffic management center, keeping track of all the vessels. And they saw that, you know what, you can have a more efficient route. So all of a sudden, one of the biggest savings for Maersk is the reduced number of crude oil, or the volume of crude oil, of a few percentage, because they can have a more efficient route. So it started with the single services around goods logistic management and ended up with an environmentally friendly, mission saving and cost saving activity and service on top of it. So that's why I think also that you can't think of all those services beforehand and make a fantastic architecture for all of it, then you will be thinking forever and ever. But identify the guiding services and then deploy the solution after it. And we're also in the securing sharing of data in the traffic management environment so that you can actually collect data from connected vehicles, from resources in the traffic environment, and to share that in a controlled way for efficiency purposes or maintenance purposes as such. Here is a lot of, we have done examples, for instance, that we put climate sensors on public transport vehicles, so that you could measure the pollution in different parts of the city by collecting that data from the public transport buses. And again, that was a single service that motivated for the bus to be connected. And now once that was connected, you have real-time information of where is the bus, where is the vehicle. So it's again a double benefit of both getting the society interesting data on the environment and getting the commercial or the operation benefit of knowing where is the asset and how well to utilize this.
Question. So what you tell us is fascinating. We hear about very smart systems, I mean, to connect and bring a new level of intelligence to those services we experience. As we have been traveling now with Swedish rail system yesterday, the traffic system that guides it very advanced, that allows for 30 different operators to act on the same lines simultaneously. Now, for Nairobi, what can we learn from this? When is the right time to leapfrog to this type of solutions? Is it a step we can take right away, or we have the challenges of the flooding, which are very practical, hands-on challenges, where even the organization may be able to respond is difficult to manage at the moment. So would these kind of systems be at help at the moment, or what is the possibility right now in Nairobi to utilize complexity like this? What do you think? Thoughts?
Depends on the cost.
Depends on the cost. Good point.
And also the technical capabilities that
Yeah, of course.
if it's already in-house or it you have to provide.
Yeah.
So have you provided this system to any African country?
Yes.
I'd be more interested at the stage at which you define the architecture going to a railway city now that you are planning. You come in at this point of planning.
Yeah, that was what we would like to be. What we see in reality is that many city planning projects start from a housing perspective or laying the road network or building factories or industries. And once that traditional city planning is done, start to think that, okay, and what do we need now for the digital infrastructure, matching this physical infrastructure. So from our side, we would like, and we think it's beneficial to come in much earlier. We're actually starting up some cooperation with companies that are active in city planning consulting to just understand that if you're planning our housing and industries, and this is how you build the transport network, where is the capability to also manage the digital information and messages? So if you are in these scenarios, it would be interesting to learn. I'm not saying that we have those services and know exactly how to do it, but just to go into dialogue, I think would be very rewarding and interesting.
Yeah, in Nairobi there is a project on intelligent transport system, and there is an organization, Kenya Urban Roads Authority, who have just advertised for the same.
Okay.
Yeah. Well, I hope you
That sounds very
will
good.
compete with others.
If you could help me with some more detailed data where we can find contacts, I would definitely hand over that to our local people and see how we could respond to it. Thank you.
Yes?
Yes, Ericsson, of course, is not new to us because we've been there for a long time. In fact, there's a time I was trying to help them get some students on the University of Nairobi. Why did you not establish the link with the University of Nairobi?
Sorry, why didn't we establish?
A relationship with the University of Nairobi, because all these things you are saying, actually, they need to be actually to be understood to begin with.
Yeah.
Of course, setting the map is not even a charade, it can be done, but they are not even well understood. But anyway, that is beside the issue, but why haven't you established the link with the University of Nairobi?
Yeah, good question. I will ask my colleagues.
Yes,
I can find it out, and if you think it's relevant, I would be more than happy to secure
He's a
that.
lecturer, yeah.
Sorry?
He's a lecturer, yeah.
Yeah, what we do.
Yeah.
I'll-
And he's an electrical engineer.
Okay,
Yeah.
good stuff. Yeah, we have the same language. Thanks for the tip. Okay, then I think that this was the end. I mean, to us, shaping the cities is part of shaping the world. And I think if we manage this correctly, it will definitely be benefits of securing a acceptance and a attraction for the citizens. It will be efficient for the business, and it will hopefully be sustainable for the society. And we hope to play a role in this, and it's up for you to judge. But thank you very much for the opportunity to come and talk to you.
One more question, yes? Sorry.
Thank you. Thank you, Ole. I wanted to find out what role have you played in air quality monitoring, especially the urban areas?
Air quality management.
Monitoring.
Yeah, as I said, we have done one example in a city of Eastern Europe where we equipped the city buses with air control sensors and then collected that sensor data into an application that maps the air quality of the different parts of the city. And depending on that, how you integrate that into the traffic management, you either limit traffic or you use broadcast warnings to the citizens. Can be many different scenarios. But that's one way to start it. Again, sensors to a central center and then dispatching information. Okay.
Thank you very much.
Over to you.
Yeah.
Yeah.
That I think was a very, very good overview of the latest technology to connectivity and connect smart systems, as Ericsson has world-class expertise in.
Thank you.
Thank you.